हेलो अस्सलाम वालेकुम एवरीवन। स्टार्ट करते हैं स्ट्रिंग मैनिपुलेशन। From string manipulation practice number 6, finding the number of vowels in a string. Someone in the last class asked, what if we like to look for few of the characters, not the characters in the range? Range means that from A to Z or from 0 to 9. Rather, they wanted to pick random characters. So with this practice, we will practice how to find out different characters in a string. This is A, E, I, O, U, finding the number of vowels in a string. All right. This might be taken two ways. Number one, what is the total number of all of the vowels in a string? Or this might be what is the number of A's, number of E's, number of I, number of U, O and U's in a string. So let's take an easier way. This is visualization. For example, we input one string. A string is this. And then we look for every character in this string and see if it is one of those A, E, I, O, U vowels. Again, we will have to run length of this string and to pick one character in each loop. First of all, we would have to either make that character uppercase or lowercase. Otherwise, we will have to look for A in uppercase and A in lowercase. So it is a good idea that either we take input in a string 1 and turn the whole string into one case, or to pick one character and then turn that one character into uppercase or lowercase and then check it. So we have taken one input and then we are outputting how many vowels are there. Okay, we might have vowel counter or A counter, E counter, I counter, O counter, U counter. It's up to you that what sort of approach you are taking, and up to your question that what they ask in the question. Either they are asking for individual vowels to be counted or as a whole. So we have one string to take input and a character which we will pick in one turn, then a counter for the loop and counter for the vowels. So we are going to count all of the vowels in one counter. Then we have to initialize. We will initialize a string with double quotations, double quotation, and we have to initialize character with single quotations, I with 0 and vowel counter with 0. First we will take input and remember with the prompt. Then we will start processing. We have to run length of this string, so we would be running a loop from first character to the last. So it is always from 1 to the length of the string. We have no idea that what will be the length of the string. It might be a single character, it might be 100 characters or 200 characters. Beta, it is going live, so it will be available on YouTube anyway. Okay, so all these classes for P2 are live over the YouTube, so you will be able to watch them later. Now, we will run the loop character by character over the length of the string which is input. We will pick one character, we will turn that character into uppercase, and then we see if the character is A, or character is E, or character is I, or character is equal to O, or character is equal to U. Since we have already converted that character into uppercase or U case, we can check only for a single case then. Alright. This underscore is used when you like to break your single statement over the separate lines. This underscore is used when you like to break one single lengthy statement that might go beyond your one screen and will have to make you scroll. Rather than scrolling, you can always break one single statement. This is a good idea for your exam as well. So leave a space and put one underscore and go to second line. Leave a few spaces here for indentation and continue with it. So from this end until this end, this is one statement. So let's say if the character that you have picked up, you have converted it to its uppercase. If it is one of these, then the vowel counter will be increased. Otherwise, you can take if for individual counters, if you want to count for A, then you be like if character is equal to A, then A counter is equal to A counter plus 1. Else if character is equal to E, then E counter is equal to E counter plus 1. If the character is I, then I counter is equal to, then this way you can go forward. As this is only for one character, you can also use case. Alright, case of character 1, and then you can have different counters for different vowels. Anyways, once you get out of this loop, you will have a counter for the vowels in the string. Now let's apply this strategy in Visual Basic and see if it works fine. So we have declared a string, character, loop counter, vowel counter. We initialized them. We took input with the prompt, and then we ran the loop through the length of the string, picked up one character, convert that character to the uppercase, and see. And over here you can see that instead of breaking it to one or two lines, I have made it 3 lines statement with the use of underscore. And then once you get out, we output the vowel counter. Let's see if it works. See, vowels in the string are 5. Let's observe this program line by line and see if you can make more sense of it. So, ZAFAR, Zafar, ALIKHAN. Okay. Now, string 1 is Zafar Ali Khan. We will pick one character at a time. This is Z, and then we convert it to uppercase. So it turned into uppercase, and then we will check it. If it is either of these A, E, I, O, U, it is not. So it will skip counting, go to the next character. Now I is 2. This is A. We converted it to this. A is uppercase, and then we see if it is one of these. Yes, it is one of these. Then we will count it. So then for F, it will skip. Then again for A, it will count. Now the counter is 2. Then R, no, it is not. then space, no it is not, then A again, it will count it, L, ignore, then at ninth position it is I, it will be counted, and then at 10th position it is space, so it will be ignored, K at 11 ignored, H at 12 ignored, A at 13 took in and it will be counted, and then at 14th the last one is N and it will be ignored. So finally the counter is 5. Alright, and then we can see. You can see over here 1, 2, 3, 4, 5. We have got 5 vowels in it. So this program works perfect, and as usual you can find these programs over my GitHub account. There is ZAK on web. Number 7, find if two strings are anagram. Anagrams are those two words which have same characters in it. Alright, anagrams are those two words which have same characters in it. It means both will have same characters, but they will be different words. Let's say an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. For example, Zafar, Z-A-F-A-R. Faraz, this is another name, but if you see, this is Z-A-F-A-R. And then Asfar, again, this is Z-A-F-A-R. Muhammad Abdullah, what if we already have capital vowels in the string? If these are capitals, they will remain capitals after the application of uppercase. Doesn't make any difference. So if I told you when I was explaining uppercase that if the characters are already in uppercase, they remain the way they are. There is no change to them. Only the characters which are in lowercase will be turned into uppercase. So if a character already in, like in my name, when I put my name ZAFAR ALI, in ALI A was already capital, or if all are capital, doesn't make any difference. So U case only is effective when we have got lowercase. If it is already uppercase, doesn't make any difference. All right, so these three are anagrams. Now what is visualization? We will have to take one input, we will have to take another input, and then we will have to make sense if the two inputs are basically anagrams. So there might be several ways. One of the first approaches will be to check if the two lengths are equal, and then take ASCII code of each character, calculate the sum of all ASCII codes, calculate the sum of all ASCII codes, and calculate the sum of the other words ASCII code. If the length is same and the ASCII code sum is same for two, they might be anagram. Now, there is one thing that you need to understand that people ask, what if two different characters sum is exactly same as the sum for another different characters holding word? In that case, yes, that is a weakness. But you see, we are not going to actually make perfect algorithms or pseudocode. Cambridge would like to see that whatever that you have thought of, can you program it or not? All right. So if you have a good thought for anything and you can program it very well, you will gain marks. All right. So we are not going to write perfect programs, but we are going to write programs which can actually serve the purpose for most of the cases. All right. Now see which approach we have used. So we have two strings for taking inputs, and then we have a flag, means a Boolean variable that we will use to see if the two strings are actually anagrams of each other. So this is a Boolean variable which will be set either true or false at the start, and then during the processing we will change it and we will check it at the end if there was a change during the process. Such type of variables which are set to one value at the start of the program and they are changed according to the situation during the processing, and we check it after the processing towards the end, are called flag. For example, in searching algorithms, if we set a flag, let's say is found false, and during the processing if the value is found we turn it to true because the value is found, and towards the end we are checking if is found is still false, we will be outputting value not found, and if is found is now true, the value would have already been output. All right. So that is how we basically make use of those Boolean variables. Not necessarily this is a Boolean variable. This might be an integer which is either set to 0 or 1. So the whole purpose of flag, a Boolean variable, is to basically analyze towards the end if something has happened during the execution of program or not. Then we have I, as usual. This is a counter for running the loop, and then we would have two sums. We are going to sum, uh, we are going to calculate the sum for every strings uh, ASCII codes. All right, and then we are going to match those. And this is the character variable which we will be using to pick up one single character to find ASCII code for that character. All right. Then we initialize all of those variables, and we have initialized is anagram true. So if any of the matches are false, then we will turn this as anagram to false, and we will check it towards the end. So sum and loops are 0. So first thing that we have to do is to input. We will input two words in their respective variables with a prompt, and then we will start the process. First, we will check if the length of string 1 is not equal to string 2, then we will turn this as anagram to false. If the two are same, anagram was true, it will remain true. And then in check 2, what we will do, we will run a loop for every character in string 1. We will pick up the character, we will find the ASCII code of that character, and we will add that to sum 1. Means in this loop, every character in first string will be uh, checked for its ASCII code, and those ASCII codes will be summed up in one of the variable, which is sum1. Same will happen for string 2, that we will run through the length of string 2, pick up one character, find the ASCII of that character, and add that to sum2. Once we get out, we will check if the two sums are same. So you see, what is anagram? Anagram is same characters when they are jumbled, they are rearranged, they make another word. In one word, if the characters are jumbled, they are rearranged, they will make another word. So essentially their sum should be same. As I gave you examples over here, ZAFAR would have same sum as FARZ, and it would have same sum as EZFR. So essentially Asfar, Faraz and Zafar are basically anagrams of each other. So their length is same, and if we find the sum of all the ASCII values for Zafar, that would essentially be the same as Faraz. All right, so these two checks are done. Then we have got check 3. In this check, these are additional checks. These are additional checks. If you like to skip check 3, you can always skip that check. But this check was made after insistence of few of the students. So what basically is happening in this check, just to avoid this possibility that these two words might be different, but their length is same, as well as their sum might be same because of the changes in characters and their ASCII values. It is not necessary that the whole of sum will be different from another word. So there might be possibility that the length of the words will be same as well as their sum. In that case, what we will do, we will pick up one character from here and we will look for that character in here. And then we will pick up another character and we will look for that character in here, and then we will pick up another character, and that is how we will pick one character in a turn in one string and we will look for that in another string, and then vice versa, we will pick up one character from another string and we will look for that character in here. For example, this might be a is appearing like twice over here and might be appearing once over here. So in that case, every time, or you may have a different character in this. Acha. As far as the count of A is concerned, we have already checked the length of these two words, so that really does not matter. But what if a different character is present over here which is not here yet, the sum is same? In that case, when we will pick up every character from here and we will look for that character in here, we might find it. But when in turn, in second go, when from this second word that one character is picked up and that is being looked for, that is being searched for in first word, it will not be found. So any case, we will be able to find if the two are exact anagrams or not. So what we are basically doing, we are picking up one character from string 1 and we are locating for that character in string 2. So what is basically happening, this locate function, when it is given a pattern in argument 2, this locate function will look for that pattern in argument 1, the string. If it finds it, the value of that position of that pattern or character is returned, otherwise it returns 0. So if any of the character from string 1 is not found in string 2, in that case anagram is false, and similarly then we will go for string 2 each character, string 2's each character, and we will look for that string 2 each character into string 1. If any of those are not found in string 1, then we will switch this is anagram flag false, and ultimately we are going to give output with concatenation that says if anagram is true, in that case it means that if we set it true and it has passed all 3 checks, and this is now an anagram, otherwise it would have been turned into false and it is not an anagram. So we will output it. All right. Okay, so this is for check 2, a visualization. These are the ASCII codes of characters in first word, which is Zafar, and these are the ASCII codes of the second word that was input, which is Faraz, and you see that the total is the same. It is merely rearrangement of the characters from one word to another, and when we sum them up, sum will essentially be the same. Okay, so let's see if this particular code works easily. So check 3 में if वाली statement वापस बता दें, मैं बताता हूँ. So Zafar for us. They are anagrams. ZAFR and FARAZ. These are not anagrams. All right, so this is actually working. Now let's see how all the checks are working. Zafar, Faraz. Okay, so the string 1 is Zafar, string 2 is Faraz, and we can see that easily. The length of both strings are same, so this check will pass and is anagram, which is actually true at the moment. Which is true at the moment, will remain true. All right. Now check 2. We will pick up one character. We will pick up one character. We have picked up one character, and the ASCII of that character, which is Z, will be summed up in sum1. So sum1 was earlier 0, now it has become 90. Why 90? Because the ASCII code of Z is 90. Then we pick up next character and we edit the sum, which is A 65. So 90 and 65 becomes 155. This way every character is picked and its ASCII of that character will be added to the sum. So sum is now being calculated, and you can see, as I have already calculated it earlier, it is 372. Now the same sum for the second word will be calculated. So we pick up one character, add the sum at the ASCII of that particular character to the sum 2, and then we will have sum of all the characters, and you see that both sums are 372 now. Since these two are same, the check that asks for if they are not same, then anagram is false. This check is now dismissed. All right. Now check 3. Time you ask for it. In check 3, we will pick up one character in turn throughout the length of all, and then we will look for that one character in another string. So we pick up one character and we will try to locate that in string 2. We picked up one character, which is Z, and we are trying to look for that character in string 2. This check only finds out if there are different characters in two of the words, and yet the sum is same. So there are possibilities. So every character has to be the same as in the other word. All right. In every word, all the characters essentially should be same as the characters in another word. So it will look for every character, and in every character from string 1 in string 2, and it has to be there in string 2. And now it is vice versa. Every character in string 2 will be picked up and it will be looked for in string 1. So let's check. Actually, all characters are found because these are true anagrams. Okay, so anagram was okay, good fine. Now anagram was true, and it is now true because none of the check made it false. So these two values are basically now true. Means they are anagram. Okay. So that is how anagram thing works. Now, next one. Find if a string is pentagram. Pengrams are those sentences which are having all of the alphabets, no matter small case or uppercase, in them. You might have heard of that famous phrase, uh, a quick brown fox jumps over the lazy dog. This is one of those sentences which is a famous pengram. Pengram means a sentence that has all of the alphabets, all of the 26 characters of the alphabets in them. So this one phrase, which is a quick brown fox jumps over the lazy dog, has all of those alphabetical characters from A to Z. So let's see how we will do it. You see, now we are going to look for, earlier what was happening, we were looking for every character of one word in anagram, every character of one word in another word. Now what will happen, we are going to find every character of alphabet in one string. So instead of taking two inputs, we will only be taking one string input, and we will create another variable which will be alphabets. We will create another variable which will be alphabets, and it would have all of the alphabets in it from A to Z, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, and we will pick up every character from that alphabet string, and we will look for that in the entered string. So we will first pick A, and we will look for that A in string which is input. Then we will pick up B. So instead of running the loop through the string that is entered, we will run the loop through the alphabets variable. We will pick up one alphabet and we will look for that alphabet in second string, or the string that we have entered. We are not concerned that what the string is entered, we are only concerned if all of the alphabets are present in the string which is entered. So we will make one variable having all the alphabets in it, sort of constant. We will pick one alphabet in turn, one character in turn. So we will run length through the alphabets string. We will pick one character and we will look for that in the entered string. Again, we will be requiring one of the flag is pengram, let's say, and we will make it true. At any moment, if any of the character is not found in the entered string, we will make that flag false, and at the end we will check if after looking for all the characters in the string, if any of the character was not found and is pengram flag is now false, we will output the entered string was not a pentagram, and if that pengram flag is now true, at the end we will output that the entered string was basically a pentagram. Let's see how we have achieved it technically. Find if a string is pengram. So pengram is a sentence that contains every letter of alphabets. For example, a quick brown fox jumps over the lazy dog. Visualization. Input 1. A quick brown fox jumps over the lazy dog. Output is entered string is a pengram. Second one is Zafar Ali Khan. Output will be entered string is not a pengram because we don't see B here, because we don't see C here, D here, E here. We can find F, but there is no G. We can find H, I, but there is no J. So you get the idea. In here you will find every character of the alphabet. So declarations is string 1, and then we have got alphabets variable that we have initialized with all of the values of the alphabets, and in this case we have initialized with lowercase values. So it means that the string that we will input, we will turn that into lowercase, so the characters match. In Pentagram, we don't concern about the case of the sentence. Rather, what we do, we either turn it into lowercase or uppercase. In this case, since the values that we have entered for alphabets are all lowercase, we will turn them into lowercase, the string one, the input. Okay, Pentagram, Boolean, as usual, I told you this is flag, and then this is one character that we will pick up in every uh, loop from this alphabet's string, and then this is the I counter that run through the loop. Now, input with the prompt, we have taken the input in the string 1 and we turn that string 1 into lowercase or lower. This basically depends. Now, process is very simple. We will pick up one character from alphabets and we will look for that character in string 1. If any of the character is not found, then we will make is Pentagram false. All right, and we can additionally put, if once the Pentagram becomes false, we don't have to look for all other characters, all remaining characters. So we can write something like if is Pentagram is equal to false, then exit for. That's it. You have to get out of this for. You don't want to look for any more characters. Once you get out, you check if is Pentagram is equal to true, then output enter the string is Pentagram. If it is not, then you output if it is not a Pentagram. So same, we have applied it using Visual Basic. And let's put that check over here again. If is Pentagram is equal to false, then exit for. Okay, now let's try this code. This exit for is taken well by Visual Basic as well. This is exit for, and for while and repeat loops, this is exit loop. All right, exit loop. For it is exit for. Now let's run this code and see if it works. A quick brown fox jumps over the lazy dog. It is Pentagram. Okay, the entered string is a Pentagram. Let's run it again. You see, if you remove this G, we don't have G anywhere else. So it's not a Pentagram. Okay, so instead of dog, I made it do. So G is gone. So since G is gone, this is not a Pentagram anymore. All right. So if it is proper sentence, a quick brown fox jumps over the lazy dog. In that case, it is Pentagram. Otherwise, it is not. And what if I put my name in it? This is not a Pentagram. Okay. So this is very simple. Create your own string of alphabets. Take input. Turn that input to the case as of your alphabets. In this case, it is lowercase. Then take one alphabet at a time from alphabets and look for that character alphabet in string 1. in any of the cases, if it is not found, then make is pentagram false and jumps abruptly out of the loop. So let's see line by line how it works. So this is Zafar Ali Khan. Now you see, we pick one character from the alphabets. This is A. All right. We look for that A and we found it. So it is not 0. So A is found. Second character B, Zafar Ali Khan. Character that is found is B. We don't have B in Zafar Ali Khan. So any string will return 0, and that will make this pentagram false. Or so that B is not found. If that B is not found, pentagram becomes false. And if pentagram is false, then it will get out of the loop and it will say this pentagram is equal to true. No, it is false. So it will say it is not a pentagram. That is how it works. Enter the string is not a pentagram. Finished. All right. So this is one simple algorithm. You should expect such size of algorithms in exam. All right. Now, ninth one. Find abbreviation of the given name. What is abbreviation? We want to output the first character of every word in a sentence. All right. If it is a name, let's say Zafar Ali Khan, then ZAK will be picked up. ZAK. All right. So find abbreviation of the given name. So we will look for spaces one after the other, and whatever the character which is after the space, we will pick that character and we will put that in another string. This way, we will have another string prepared throughout the loop, which is basically having all the first characters of the word, and that will become the abbreviation. Let's see how. Visualization is a quick brown fox jumps over the lazy dog. You see, a quick brown fox jumps over the lazy dog. All first characters of the words A, Q, D, F, J, O, T, L, and D. All right, and if it is Zafar Ali Khan, we have what? ZAK as abbreviation. So again, we would have two strings, one to take input, the other one is to collect abbreviation in it. I to loop through the string. Character is the character that we are going to pick from the first string. Then we initialize all strings with double quotations and character with single double quotation. This is said to be null value. We will initialize strings and characters to null only. The difference is that strings are being initialized with double quotations and to null, and characters are being initialized to null using single quotations. Now, any number will be initialized to 0. We will input with a prompt and we will turn the whole string to its uppercase, because this is a simple thing that abbreviations are always given in uppercase. So whatever the value that is being input will be converted to its uppercase and assigned back to it. And then the first character will be the first character of the sentence. Means if it is Zafar Ali Khan, Z is the first character will be in abbreviation. So what we do, we make string 2 left from the string 1 one character. We pick one character from string 1 and assign it to string 2. All right. Then we start the process. We start the process. We pick up every character. If the character that we have picked up is a space, then whatever the subsequent character after the space, if let's say in my name it is Zafar Ali, all right, in Zafar Ali. So ZAFAR, this Z has become the part of a string 2, and then we run through the characters. If the character is a space, we are going to pick this character and we will pick this character and put in string 2. This is exactly what is happening. We have picked up one character. If that one character is space, then the subsequent character is space plus one character from the, let's say if space is at sixth position, sixth location in the string, we pick one character from the 7th location and we will add that towards the end, merge that with string 2, which is already Z now, and that is how it will run. We go forward, we find another space at this location, which is 10th location, and from 11th location we will pick K and we will put that in string 2, and then we will output that abbreviated string is a string 2. Let's see if its implementation in VB actually works. Same process, same working, with 4 to 5 to 6 changes in Visual Basic. As you would have seen that all of the codes in Visual Basics are more or less like pseudocodes. That is why I prefer Visual Basic over other languages when we are learning pseudocodes. Remember, the prime focus should be over the pseudocode, as exam will ask for pseudocodes only, not the language code. All right, so let's run this and see if it works fine. ZAK, and then let's enter it in small. Since we have already made it in uppercase, this works fine. ZAK. All right. So this is wonderfully done. Let's see. Now, the last one. Until here, from 1 to 9, it was a string manipulation. We were manipulating a string for different reasons, for different purposes, for having different outputs, for different checks and all. But there is one more reason for a string, and that is validation. Means sometimes in past papers it is asked to enter a string, but as per the given format. So if the format is given, you would have to enter the string the way it is expected by the program as per the given format. So this is a validation. Validations are checks which are done or performed by the computer when you are entering data. These are small written programs, short codes behind every field of data that is being entered. Behind every field of data that is being entered. So these codes work. You are already familiar with those. For example, you see a message, you cannot leave this field blank. The value does not have such and such character. The value should be between these two ranges, whatever. All these are called what? Validation checks. All right. So this 10th is a bit different from whatever that we have done before it, because they all required your logic, your own logic. Because from this 1 to 9, all of the string manipulation practices might have taken different forms as per the understanding and logic and reach and experience of the programmer. But in validation, this is fixed way doing it. So let's see how it works. String validation. Now, string validation. First, we need to visualize what we are going to do. Uh, Not always, but mostly 9 represents any digit from 0 to 9. Small a represent any small alphabet from A to Z. And then A, capital A, represents all capital alphabets from A to Z. Let's say it means that you have to enter first 2 digits, and at any position that digit might be from 0 to 9. It is not 9 itself, but this 9 represents any digit from 0 to 9. Then these are the characters other than the alphabets and numbers. It means that these characters have to be the way they are and where they are. So I call them fixed locations. All right. So you have to enter any digit from 0 to 9 twice, and then you would have to enter dash, and then you will have to enter alphabets in small from A to Z at 3 positions. All right. And then you will have to enter hyphen or dash and then 3 digits. All right. So if I make input 1 2 1 2 fits in, then dash fits in, and then XYZ fits in, then dash fits in, and then 3 digit fits in. So this is valid input. So the first check should be the length check. All right. Whatever the length of this, if the input does not comply with that length, it means that this is not a valid string. Remember, over here, we are not going to check for something that is there. Rather, we are going to check something which is not there. All right. If it is length, if length is not equal to, if it is dash, if that location's character is not equal to. Okay. So let's see. Working. All right. Now, how we will work? Let's say we have got this format: 3 digits, hyphen, 3 small alphabets, hyphen, 3 capital alphabets. We will have 3 checks. Number 1, the length check. Number 2, fixed characters. Now, what are fixed characters? These are fixed characters. They have to be where they are. They have to be what they are. All right. And then groups. This is one group. This is another group. This is third group. Okay, so that is how we will break it. And this is my way doing it. You might have a different way, but I think that this is the best, shortest way for having a validation check done over a string. So let's check fixed characters and then groups. Let's learn about it. So we will first take input in string 1, then we use this counter for groups checking, and then we have character that we will pick up from the string in every turn, and then we would have obviously a flag which is boolean. Then we initialize all of them, then we take input enter code as this. Why we have used double quotations? Because we wanted this quotation to be the part of the output. All right, this has to be the part of the output. Now, once we take input, then we go for check number 1. Okay, we go for check number 1, and that check is what? If the length of the string is not equal to 11. So see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If it is not equal to 11, then is valid is equal to false. Now, check number 2, fixed characters. This is 4th location, 5, 6, 7, this is 8th location. So we have to check if the made of a string 1 at 4th location, 1 character is not equal to hyphen, and the character, 1 character at 8th location in string 1 is not equal to hyphen. So this is for fixed character. Let's say if we have got several fixed characters, then this and would go on. Okay, okay, Manu. All right. Now, second check, third check is groups check. So what basically is happening, the first group runs from first location to third, second group runs from fifth location to seventh, third group runs from ninth location to 11th. So we will pick every character and we will check that if every character in first group is between 0 to 9. If it is not, then we will make is valid false. Then we will run a loop from 5 to 7. We pick every character and then we will look for it if it is in between small a and z, and then we will look for capital A and capital Z from 9 to 11. So this is group 1, this one, which is from 1 to 3. So for I is equal to 1 to 3, character 1, we picked up one character and we check that if that character is from 0 to 9, and if it is less than 0 or greater than 9, it means that it is anything but 0 to 9, then we make is valid false. Now for second group, it runs from 5th position to 7th. We run this loop from 5th position to 7th position, and we pick one character and we will check that if that character is not between 0 or A to Z. If it is less than A, means it is not A, or if it is greater than Z, it means that it is not small A, B, C, D, then is valid will become false. And then for group 3, group 3 runs from 9 to 11. We will pick every character from 9 to 11, one character at a time, and we will check it. If it is less than capital A and greater than capital Z, it means that it is anything but A to Z. In that case, we will make is valid false. So this technique of working out a string for length first, then fixed characters, and then groups, identifying groups and look for those groups. In turn, every group should be having different characters, and every character should pass through the check of being what it is expected to be. All right, so afterwards we see if is valid is valid. If is valid means if is valid is equal to true, then we will write valid code, otherwise we will write invalid code. Let's see how this whole thing works when we apply it. This algorithm might look longer to you, but the thing is that this is not something which is basically tough to deal with, because it is straightforward. All right, whenever it will be done, it will be done same way. Okay, so let's see. So enter code to validate as 999999 dash DFE dash ASD. So it is valid code. Let's see if we enter another one. 999, instead of dash I put plus, then ASW dash AQW. Only change that I have made is this plus. Okay, it still says valid code. All right, this is one of the error that appears most to me. This is my mistake. Basically, instead of this and, we have to put or over here. See, so if it is 968 dash ASW dash AQW, it is valid code. If we run 999 plus AQW dash QWE, this would say now invalid code. Okay, so you have to be careful about it, this and an or thing. And this only becomes obvious once we actually apply the code. So do not rely upon your understanding. Always try your code using Visual Basic and then understand that the code that we have written is correct. Such little mistakes are called logical mistakes, and they keep appearing when we learn about the coding. All right. So this concludes all of it. String manipulation is completed. Over my GitHub, there is an assignment. After learning all of it, if you could perform few of those assignments, this is github.com/ZAK on Valve. All right, Here we go, string manipulation. If you don't see it over here, then go to repositories, and then you would have string manipulation there. In string manipulation, we will have few assignments over here. If these are not, I will upload them. Practice string manipulation commands. Okay, there are assignments for Python. So I will upload few assignments over here so that you could practice those assignments as well. Anyways, be aware that at this particular GitHub account, all of the codes related to AS and A2 are present. Okay, and not just that, we have one repository which is computer science. In computer science, we have A level, and all of the boards, class boards that I have created, I have put them over here. Okay, so you can see all class boards which I have made during the classes. I have put them over here. They might also be useful for you. So the next topic will be the structured programming. Structured programming is decomposition, learning about procedures, functions, how to break the whole program and everything. We will start that from next class, which will be Friday. And meanwhile, if there are any questions, please do shoot those questions out in your respective WhatsApp group or over the Facebook in post and comments. I will definitely be answering those.